Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5.5 day 2, solving polynomial equations again, but we're using a little bit more involved in this case. Okay, so the first example here I've got is a word problem. So make sure that as you work through, you're just modeling it, and it's just going to be modeled with a polynomial. So it says here, determine the dimensions of the cubes below if the length of the smaller cube is 1/2 the length of the larger cube, and the volume of the shaded figure is 5,103 cubic centimeters. So just the shaded right here is the 5,103. What we showed here is if we take the normal cube, which was 2x, 2x, and 2x, half of that is going to come out to x, x, and x. So we're cutting out this corner cube out of it. What that means is to represent my volume, I am taking the volume of the big cube minus the volume of the small cube. So volume of a cube is just every side raised to the third power. So that means I can take this 2x to the third power minus x to the third power. Okay. Now, when I do that, because we know what that shaded region is, that's going to equal to 5,103. So 5,103 like that. So this is a polynomial. I'm just going to go ahead and take care of my exponent properties and simplify a little bit. So remember, it's 2x to the third. So that's 2x times 2x times 2x gives me 8x to the third minus x to the third is equal to 5,103. So now I can combine 8x and negative 8x to the third minus 1x to the third. So that gives me 7x to the third equals 5,103. Divide by 7 to both sides. So x to the third is equal to, double check with my calculator, 729. From here, if I have x to the third is equal to 729, now I just need to do cube root. Instead of doing square root, if I have something squared, now we're going to do the cube root to both sides. Okay, so if I take the cube root of that number, let's see here, 729 comes out as 9. Okay, what we're finding is a number times itself 3 times. So 9 times 9 times 9 gives me 729. So that's what cube root is finding. Now, any calculator should be able to handle cube root on this one. Make sure you find that button. So the question says, determine the dimensions of the cubes below. We just found it to be 9 right here, and we're dealing with centimeters. So this cube, the small cube, is going to be 9 centimeters by 9 centimeters by 9 centimeters. The larger one is 2 times 9 in all the cases. Okay, so the larger one is going to be 18 centimeters by 18 centimeters by 18 centimeters. Okay, and that's the dimensions of both cubes in this case. The other solving we'll have to do is right here, something like this. Let's get a little bit more complicated. So x to the fourth plus 21x squared minus 100. We didn't talk about this in the previous video because it's something, this one is a little bit different. We only have 3 terms. We also jump from x to the fourth down to x squared. So here's what we can do with this problem. We're going to treat it like I'm going to call a different variable, we'll call it u. I'm going to call that x squared. What that means is if I square that, that's the same as taking x squared to the second power, which is x to the fourth power. Well, what if I replace these with u and u squared? So if I do that, x to the fourth is the same as u squared in my scenario here. That'll be 21u minus 100. This is now just a quadratic. I could solve this much easier, and that's what I'm going to do. We'll solve by any method you want. I'm going to choose factoring here because if I look at what multiplies to a negative 100 but adds to a 21, that is going to be a positive 25 and a negative 4. So I got u plus 25, u minus 4 equal to 0. Okay, so then I can take this, remember, u is x squared. So I'm going to bring that back in now. X squared plus 25, x squared minus 4 equals 0. According to zero product property, I can separate these two like this. So the one on the right here, if I solve that, I could do some factoring if I want to, or I could just do square root property if I add the 4 over. Either way, I'm going to have +2 and -2. And if I solve those two, I get x equals at -2, x equals +2. These are my two real solutions here. For x squared plus 25, I can't really factor that because it's a positive. I can subtract it over to make it a -25 and then do the square root property. So remember, when I have the square root of a negative, that's automatically going to be I. So this is going to be the square root. I'm going to have I in my answer, but also I can take the square root of 25. That's a perfect square. So square root of 25 is just 5, and then I have an I. But square root property says it's a plus and -1. So we actually have two complex solutions as well. So I have two real and two complex. So that's where I get down here as my final answers. I got +2, -2, +5i, and -5i. So that's our all four possible answers here. Okay. And that's it for my solving them. Be aware that sometimes you have to solve like a quadratic. You either do something like this where you can get quadratic or square root property, or you have to solve it with quadratic formula. Bottom line is that's the way we can get our complex solutions here. But we can also have the two real solutions like this. Okay. All right. That is it for 5 day 2. All right. Take care, everybody.